Hey my dear data friends, it's Nicola from Data Mozart. In this video I want to show you how you can quickly and easily optimize your Power BI report. A few weeks ago I was tasked with performance optimization for one Power BI report. And of course, there can be dozens of different reasons why your Power BI report performs slow. But in this video I want to show you some low-hanging fruits and how you can very quickly and easily optimize a Power BI report by applying some very basic optimization techniques. Stay tuned! I'm in the Power BI desktop, or to be more precise, I'm in Power Query Editor. And for demo purposes in this video, I'll be using a fact table that contains the data about chats performed by a customer support department in some imaginary company. This table includes approximately 9 million rows, which is not considered a large table in the context of Power BI and analytical workloads. For the sake of simplicity, let's pretend that our model consists of only this single table. And finally, semantic model is configured as an import mode model. Data was loaded into Power BI from the underlying data source, which is in this case a SQL Server database as is, which means without any additional optimizations applied. For this exercise, I would like you to focus on two columns. DateTM start UTC, which stores the information about the chat starting date in UTC time, and this column is of datetime data type. And chat rating, which is chat satisfaction rating submitted by the customer, stored as a decimal number with 5 digits precision. Before I show you how to optimize the semantic model in literally 5 clicks, let's check our starting point and understand the metrics behind our model. For that purpose, I'll use a fantastic free tool, DAX Studio, and its built-in Vertipack analyzer feature. As you may see on the screen, the total size of the model is 642 megabytes. And if we drill down to see the information about specific columns, you may notice that the DateTM start UTC column is by far the most expensive in our model, consuming exactly 2/3 of the entire model. If you're wondering why the size of the DateTM start UTC column is so huge, you may want to refer to my article that I wrote that explained the concept of cardinality and how it affects the data model size. I'll share the link to the article in the description of this video. In a nutshell, the higher the cardinality of the column, which means the more distinct values in the column, the harder it is for Vertipack to compress the data in an optimal way. And this consequentially leads to a bigger data model size and slower queries. Now, before we jump into modifying the semantic model structure, it's of key importance to check with business stakeholders if your decisions could potentially impact data accuracy and if a modified semantic model will meet their expectations. Trust me, I made this mistake myself a couple of times and then had to do double work because of the lack of communication. The main question is, what is the lowest level of detail or granularity for displaying the data in the report? In 99% of cases, if we are talking about the analytical scenarios, reports focus on providing the data on a daily level. On some rare occasions, you might want to include analysis per hour, whereas creating analytical reports to display numbers per minute is an extremely isolated requirement. In my case, the requirement was to analyze the data on a daily level. So why on earth should we store information about hours, minutes and seconds in Power BI? Let's go and simply change the data type of DateTM start UTC column from datetime to date. I'll click in the top left corner of the column and change it to date. Let me stop for a second here and examine a few important things. First of all, I've used Power Query and its rich graphical user interface to apply the desired data transformation step. Instead of doing this, I could have also created a SQL view in a database and implemented data type conversion in the view definition. Another approach might be to split the existing datetime column into two separate columns. One would contain only date information, whereas the other would keep the time portion. This technique would definitely reduce cardinality, but then you need to invest additional time and effort on the report development side, where you would need to bring date and time data together by rewriting your measures. Hence, I advise people to stay away from this approach, unless they are dealing with really huge amounts of data and if there is no other viable option for optimizing the model than splitting a column. Okay, so now I'll hit close and apply and then check metrics of my report again. This is awesome! By simply clicking twice in the Power Query editor and switching from datetime to date type, the column size drops from 440 megabytes to 9 megabytes. And the entire model size is now, let's check, 222 megabytes instead of 642. Let's face the reality and ask ourselves, how many times do our end users really need to see a value like 123.45678 in their reports? Okay, maybe there are certain scenarios where this level of precision is truly needed, but as in the previous case with datetime columns, in 99% of cases, it's absolutely acceptable to have the same number displayed as 123.5 or 123.46. Let's play safe and opt for the latter, keeping 2 digits after the decimal point. Again, I'll apply my transformation in the Power Query editor for chat rating column. I'll go to Transform tab and then under Rounding option I'll select Round. I define 2 decimal places for my column, and as you see, now the column contains values displayed as with 2 digits after decimal point. Again, hit close and apply, and let's wait to see how the metrics look like now. Again, 2 clicks in the Power Query editor and our column is 30% smaller, because we managed to reduce its cardinality. In terms of memory savings, this might look like trivial compared to the gain we obtained by changing the date-time column data type, but in large models, and especially with higher cardinality, this technique can also result in significant memory savings. Here I would like to emphasize another point. You might think that changing a data type of this column from a regular decimal number to a fixed decimal number could produce a similar outcome, but this is not true. Explaining details about various data types is out of the scope of this video, but I want to assure you that you will see, even though you will see only 2 digits after the decimal point in the chat rating column, and let me show you what I'm talking about. So instead of rounding, I'll revert this, and instead of decimal number, I used fixed decimal number. So again, you see just 2 digits after the decimal point, but although you see only 2 digits, in reality a fixed decimal number type always stores 4 digits after the decimal point. And let's check again what happens with the metrics of our semantic model. As you may see, we are again back to 10 megabytes, which is almost the same as in our original case. You see that almost nothing changed in terms of cardinality and memory footprint of the column when I changed its data type to fixed decimal number. In this case, rounding had much more impact on the column size than changing its data type. To conclude, optimizing the Power BI semantic model doesn't always have to be a daunting and time-consuming task. You can often celebrate many quick wins by understanding how the data is stored under the hood and how to implement various cardinality reduction techniques to reduce the data model size. As you witnessed, with just a few clicks here and there, I was able to significantly improve the performance of the Power BI semantic model. Hope you enjoyed this video and you learned something useful. If you like this video, please make sure to click this like button down below. Also, if you don't want to miss any other Power BI tips and tricks and also Microsoft Fabric tips and tricks, make sure to subscribe to a Data Mozart YouTube channel. See you soon!